Good day, students. Today I want to talk about covalent bonding, the basics of covalent bonding that you are expected to know in chemistry, especially at ASA level, that is chemistry 9701. You'd actually find out that if an atom is going to form some covalent bonding, the minimum number of bonds that it forms is usually directly proportional. It's actually a function of number of lone pairs that is found in the atom. I'll just take an example of nitrogen, for instance, okay? Let's just look at nitrogen as an example, okay? Nitrogen, we want to do the electronic configuration for nitrogen, okay? If we are to remember, we can also use the box notation for doing the electronic configuration for nitrogen. Nitrogen is atomic number 7, okay? So we have 1s and we also have our 2p. Remember that our p is px, py, and pz. So if we do our electronic configuration for nitrogen, you're actually going to find out that for nitrogen, you're going to have 1s2, okay, 2s2, and then you're going to have 3, okay, unpaired electrons, okay. So nitrogen, basically, nitrogen ground state, okay, ground state for nitrogen, you're going to see that it has 3 unpaired electrons, okay. No wonder why nitrogen can actually form a compound such as ammonia, even ammonium, okay. Right, so we are simply saying here nitrogen in its ground state can actually form 3 covalent bonds, okay. So we can have NH3, for instance, because we have 3 unpaired electrons. So the electronic configuration for nitrogen in its ground state is 1s2, 2s2, 2p3, okay? 3 unpaired electrons, and then we can form 3 covalent bonds, okay? But we have some compounds such as carbon. How come carbon can form 4 bonds, okay? We have to explain that. Let's analyze what happens with the story for carbon, okay? Let's look at carbon, the ground state electronic configuration, okay? Carbon, the ground state electronic configuration. Again, we're going to use the box notation, okay? We have carbon, and remember, carbon is number 6, okay? Again, we do the same procedure, okay? Let's say carbon, 1s2, 2s2, and then we have 2p2, because carbon is number 6, 1s2, 2s2, 2p2, okay? Right, so we need to be in a position to explain what happens for carbon to form 4 bonds, such as we have CH4, okay? So this is carbon in the ground state, okay? So there is something that must happen as the bonds are being formed, okay? We must be in a position to account for the formation of 4 bonds, okay? So we can actually come up with another electronic configuration, and then we can actually say carbon, okay, in the excited state, okay? Carbon in the excited state. Sometimes you see chemists can actually do that. Carbon with an asterisk, okay? There's something that happens because we should be in a position to explain how come carbon will form 4 bonds around it, okay? Something must happen, all right? So as the carbon form bonds, there is something that happens here, okay? Right? Again, we have our 1s here. This is 2s, and this is 2p, okay? 1s, 2s, 2p, all right? These 1s electrons, or these 1s electrons, are not involved in bonding. They are in the innermost shell, or in the innermost orbitals, okay? So what happens is during bonding, okay, one of the 2s electrons is promoted to the 2p electrons. The energy involved, or the energy given out during bond formation, actually causes one of the 2s electrons to be promoted to the 2p, okay? This was a vacant orbital, so one of these goes And we have now 3, okay, unpaired electrons in the p, and we also have 1 unpaired in the s, okay. So this second shell now has 1, 2, 3, 4 unpaired electrons, okay. So we can then explain as to how carbon would form 4 bonds. We started off with 2 unpaired electrons, a vacant orbital. During bond formation, one of the 2s electrons is actually promoted to the vacant orbital there. And as a result, we are going to have 4 unpaired electrons. So it's not surprising that when we are going to form methane, for instance, okay, a compound called methane with CH4, okay, I can then say, okay, we are going to have 4 hydrogens coming along. 1 hydrogen, 2nd hydrogen, 3rd hydrogen, 4th hydrogen, okay? So in that case, we are going to use s orbital and 3 p electrons, okay? So we are not only going to use 1 orbital, we are going to use a mixture of orbital, okay? Because we are using a mixture of orbital, we can borrow that term from biology, hybrid, mixture of breeds, okay? So in this case, we are going to have s and p orbitals being used, and we are using 1 s orbital and 3 p electrons. So in this case, we are going to say, okay, we have used 1 s orbital and 3 p electrons. So we have a hybrid of orbitals being used in the formation of methane. And that case is called sp3 hybridization. So methane, okay, ethane, all alkanes, they tend to follow this rule, sp3 hybridization, okay? In my next video, I'm going to explain sp2 hybridization and sp hybridization. I hope you have understood what we mean by nitrogen in the ground state, carbon in the ground state, and carbon in the excited state, and how we are forming what we call sp3 hybridization. I hope this lecture has managed to help you, and just analyze my whiteboard as I come to the end of this session. Remember, if you like this video, subscribe to my channel and also share with your friends so that you will be in a position to revise for your exam. Thank you. Bye-bye for now.